Hey, let's talk briefly about direct translation. It's kind of the first step to problem solving, and problem solving is one of those things that you're going to stumble upon in Unit 9 that can be a little difficult. It'll come up again in Unit 10, but Unit 9 is where it's going to be a little bit harder, okay? So let's go over some of the basics. Okay, so problem solving. Let me adjust a little bit. Don't know what I just did. Okay, all right, problem solving. This comes up in algebra. It can really come up in any kind of math class. You actually did a lot of problem solving back in Unit 1 if you were required to complete Unit 1, or not Unit 1, Tier 1. Anytime you have a word problem. So when you're basically taking a real world scenario and you're coming to some mathematical conclusion, that's problem solving. But you see it a lot when you're in algebra. And the thing that's tricky in algebra is you have some kind of unknown piece, okay? So problem solving comes up in algebra. You're always looking for an unknown. And when you do this introduction to algebra, like where you're dealing with algebra, like when you're solving linear equations in one variable, which is Unit 9, you have to assign the variable, okay? And that's kind of the biggest piece here is assign the variable to what you know nothing about. Okay, so if we don't know what some value is in the problem, we would assign it some variable like x. Okay, and that's going to be a big deal from now until the end of problem solving. Always think and ask yourself, what is my variable? What do I know nothing about? What do I assign my variable to? Okay, and there are many, many types of problem solving questions that you could come up in an algebra class. You can do really basic stuff with direct translation, which is what I'm going to focus on in this video. You could do work where you're dealing with formulas. So in some case, you create the formula using this idea of direct translation, and then you use that formula to answer questions. There are percent problems, so percent markup and percent markdown is generally where the focus is in this type of unit. You could deal with something called uniform motion. You could deal with just basic direct translation problem solving. There are some geometry problems. So there's kind of like this world of problem solving type questions that could come up. I can't possibly go over every single type, but I want to be able to give you an overview. Okay, so to start, we're going to talk about something called direct translation. All right, this is the process of converting words and sentences into algebraic expressions or equations. Okay, and for equations, and like I mentioned on the previous slide, don't forget to assign a variable. In some questions, they're going to tell you that they want some value to be n or some value to be x, but not all the time. Sometimes it's completely up to you to assign the variable to what you don't know. So don't forget to assign the variable. Sometimes you have to assign more than one variable. So don't forget to assign the variable to the unknown. Okay. Now, one thing that's going to be really helpful is to have a list of words that would indicate some kind of operation in math. So I'm going to take like a handout that I had made years ago, and it gives you just, it's a table of information, and it basically gives you words or really short phrases that would indicate addition, subtraction, multiplication, division, or equality. Okay, so I'll post that in Moodle. But for now, let's look at a few things. So what if I told you that the sum of a number and 9. Okay, so in this case, I'm just going to leave it as a simple statement, the sum of a number and 9. Okay, I'm not going to go any further than this. The first thing you want to do is look for words that would indicate equality. So is, equivalent to, yields. And in this particular case, we don't have a word of that nature. Okay, so that tells me that this is going to be just a basic algebraic expression. So no equal sign. Okay. So let's look for keywords that would indicate addition, subtraction, multiplication, or division. So right here, I have the word sum. Sum means add, okay? And then I have this short phrase, a number, okay? Well, I don't know what a number is. It's unknown to me. Some number, any number. So this is your variable right here. So we're looking for the sum of some number, which is going to be our variable, we'll call it x, and 9. So I basically want to take x and I want to add 9. This right here, x plus 9, is the sum of a number, x, and 9. Let's try another one. You'll have to forgive me. My handwriting is always terrible when I write on my laptop or on my tablet, okay? So again, we want to look for a word that would indicate equality, is, equivalent to, equals, yields. We don't have anything like that in this question, okay, or in this statement. So we want to start looking for words that would indicate an operation. So think addition, subtraction, multiplication, division, all right? So I noticed this right here, difference. This means subtract. Ah, okay. So I want to subtract twice a number, okay? Well, I don't know what the number is. It could be anything. So this is my variable. And I want you to be really careful here. We want twice that number, okay? So let's say the variable is x, and we want twice that. That means 2 times x. So I'm going to call this 2x. And then we simply have and 8. So we want the difference. That means subtract 2 times a number, twice a number, and 8. Now, with subtraction, you have to be really careful because order matters. We literally have to take twice a number and then subtract 8. So we would get 2x minus 8, or the difference of twice a number and 8. Let's look at another one. So this one is really similar to the one we had before. It's worded differently. It says 8 less than twice a number. Again, there's no word that would indicate equality. There's not a word that would be like is or equals, equivalent to, yields. So there's nothing like that. That tells me I have just another algebraic expression, no equal sign. All right. So I need to start looking for words that would indicate an operation. And I see right here that I have less than. Less than would indicate subtraction. Okay. And I want 8 less than twice a number. So again, I have this word or this phrase, a number. I don't know what the number is. It's completely unknown to me. So this is going to be my variable. And just like in the last question, I want twice that number. That means 2 times the number. So 2x. So I want to take 8 and subtract it from 2x. So this is going to be 2x minus 8. Subtraction is one of the hardest ones to deal with because the way it is worded really does matter. So let me show you how we could change this one a little bit. So the difference in this slide compared to the last slide is so subtle. So let's go back to the last slide really quick. So in the last slide, in the last slide, I had 8 less than twice a number. So that tells me I want to take 8 away from twice a number. But now I have 8 less twice the number. So this is telling me I want to take 8, and less still means subtract. So what I want to do is I now want to subtract twice a number, which we already know from the previous 2 examples is 2x. So this one is actually 8 minus 2x. Okay, it's very subtle. You don't generally see this wording very often. Okay, you'll most of the time see the previous two examples, the one where we had the difference of, and then you just go in order. You take the first thing, you subtract the second thing, or you could see something less than something else. So 8 less than twice a number. So you'd still take twice a number, and you want to take 8 away from that. It's this third one that's a little tricky. 8 less, twice a number. It's weird. You don't see it very often, but I wanted to show you. Okay. Another thing I need to show you is the product of a number and, let's say, 5. Now, we don't have a word that would indicate equality. There's no is equivalent to, equals, or yields, or anything like that. So this is going to be just another algebraic expression. This word product right here is what we're looking for. This indicates the operation of multiplication. Okay, so we want to multiply some number, we don't know what, and the number 5. So we're going to take some unknown number x, and we want to multiply it by 5. And when you're dealing with algebra, you don't actually have to use a multiplication symbol. You just write the two things side by side if you're dealing with a variable. Okay, so we definitely have a variable. This number, we're going to call it x, and 5. You would absolutely write it 5x. You put the variable after the number. This number is called a coefficient. You should already know that from a previous lesson. So you write the coefficient and then you do the variable second. So coefficient first, variable second. Another one I want to show you is quotient. You don't see this a whole lot, but when it does come up, you need to know how to write it. So we could say the quotient of twice a number, whoops, and 11. Sorry, that one got really, really sloppy there. Let me fix this. There, that's a little bit better. So the quotient of twice a number and 11, again, we have no word that would indicate equality or an equal sign. So we want to start looking for a word that would indicate the operation that we're looking at. So quotient is division, all right? So when you see the word quotient, you need to think divide. And what I want to make very clear to you all is when you're in algebra, you don't use this symbol anymore, okay? Instead, we want to do fraction form. So use fraction form, all right? It's not wrong to use the division symbol. It's just kind of wacky. It's a little awkward, okay? So we just don't use that division symbol very often in algebra. Okay, so we've got quotient. We know it means divide. We know we're going to write this in fraction form. And we want to divide twice a number and 11. Twice the number, we don't know what the number is, so we're going to call that our variable. We'll use 2x again. So this is 2x divided by 11. All right. So again, it's not wrong to say 2x divided by 11. It's just kind of wacky. It looks sloppy and it really complicates your algebraic expression. The fraction is just a lot smoother. It's a lot cleaner. Okay. Now, the last couple of examples I want to show are examples where you would use parentheses. And I do want to be very clear. The wording is subtle. So I kind of want to compare two things right now. So let's say we have the sum of 3 times a number, whoops, and 1 versus 3 times the sum of a number and 1. After subtraction, this is one of the more complicated types of examples, and it's very it's not hard, but students tend to sometimes struggle with when to use parentheses versus when not to use parentheses. So here we have the sum. We want to add 3 times a number and 1. So we quite literally need to figure out what 3 times a number is. That's just 3 times x. We don't know what the number is. We assign a variable to it. And to that, we want to add 1. What's different in this second statement is we want 3 times the entire sum. So I want 3 times the sum, and the sum happens to be between a number and 1. Now, the wording is subtle. On the surface, you've got a 3, you've got an X, you've got a plus sign, you've got a 1. They look like they could almost be the same, but those parentheses really make a huge difference. Keep in mind, this right here is really 3 times X plus 3. Okay, that's nothing like 3x plus 1. They're very different. Okay, so be on the lookout for 3 times a sum or twice a difference or half a sum, a third of a difference. Okay, if you have some statement where you're multiplying it by a sum or a difference, that's when you would use your parentheses. All right, so let me stop my share. I moved my tablet down, so now I feel like I have to like bend over so you can see me. That's just a really quick overview of direct translation. It's this idea of converting English words, sentences, statements into math, okay? This was specifically right here, just algebraic expressions, okay? So I'm gonna go back and I'm gonna do just a couple of examples where we actually have equations, okay? So the first however many examples we did, none of them had an equal sign, okay? So I wanna show you what it looks like when the statement is asking you for an equation versus just an expression. And remember, the difference between an equation and an expression is that equal sign. If you have an equal sign, you're dealing with an equation. You've got 2 statements that are equal versus an algebraic expression where you're just dealing with one single statement all on its own. Okay, so really quick, let's go back and let's look at a couple of equations. Okay, so direct translation, same old, nothing new there. But this time we're going to look at equations. Okay, so some words that indicate equality, and that means we're looking for that equal sign, is, if I say this side is the same as that side, the word is would indicate an equal sign. Equals, we already know that. Is equivalent to, kind of a longer phrase, but it still means equals. You could also see the word yields, okay? These are just 4 common ones. You could certainly have other words that would indicate equality, but these are the 4 that you're probably going to see the most often, okay? So let's look at an example. I could say the sum of a number and 14 is -1, okay? So I've got this word is right here. It's telling me that the sum of a number and 14 is the same as -1. So this word is quite literally my equal sign. So what we do is we take the entire left-hand side, and that's going to go to the left of the equation. And then the entire right-hand side is going to be the right-hand side of the equation. So I can go ahead and say the left-hand side is -1. Now, in this case, the left-hand side is the one that's a little more complicated. First of all, we have to look for what operation we're dealing with. Sum means plus. We need to figure out what our variable is. It's just a plain old number. And then we're going to take that number, some unknown, in this case x, and we're going to add it to 14. So we would say x plus 14 is -1. So this translates the sum of a number, x, and 14 is -1. And here you have it. Let's look at another one. So half the difference of a number and 2 yields the product of that number and 5. This one's a lot more complicated than the first example that we just did. First of all, always look to see if you have some kind of word that would indicate equality. We do. In this case, we have yields. All right. Yields is quite literally my equal sign. All right. Everything before the word yields is going to be the left-hand side of our equation. Everything after the word yields is going to be the right-hand side of our equation. So let's go ahead and look at everything before the word yields. We have half the entire difference. That means we want to take half of some difference. We use parentheses here. Our difference is going to be of just a number. Some number, we'll call it x, and 2. So we want x minus 2, but we only want half of that. You could also write this as x minus 2 all over 2 if you feel comfortable, but for the sake of this problem, I'm just going to leave it as is. All right, so we have half the difference of x and 2, and that is going to yield or equal the product of that. Whoops, I forgot to put number in here. The product of that number and 5. So this is saying take that same number x and multiply it by 5. So half the difference of a number and 2 yields the product of that number and 5. Let's look at one more. So let's say we have 3 times the sum of a number and 23 is equivalent to the sum of 3 times a number and 17. Okay, so you want to look for a phrase or a word that would indicate equality, and we have that right here. Is equivalent to, that is our equal sign. Everything before the statement or phrase is equivalent to is going to be the left-hand side of the equation, and everything after the statement is equivalent to, or the phrase is equivalent to, is going to be the right-hand side of the equation. So let's look at everything before the phrase is equivalent to. We have 3 times the sum. That means we want 3 times an entire sum, okay? So we're going to take 3, multiply it by whatever this sum is. The sum is of a number and 23. So sum means plus, all right? So we're going to be doing something plus 23. And in this case, a number, we don't know what it is. We assign a variable to it, all right? Is equivalent to is our equal sign. And then we want to take the sum of 3 times a number. And with these equations, we're dealing with linear equations in one variable. Use the same variable. So don't switch it up and use like a z or a y or something. Stick with x, okay? So this time we want the sum of 3 times a number and 17. So again, sum means plus. So we're going to have plus 17. And that 17 is going to be added to 3 times a number. Well, that number that we don't know is x, and we want 3 times that. So we have 3 times in parentheses x plus 23 equals 3 times x plus 17. So again, 3 times the entire sum of x and 23 is equivalent to the sum of 3 times just x plus 17, right? A little tricky. The big thing with direct translation is you've got to read the question very, very carefully, okay? Read it, reread it, read it again, okay? Make notes. Don't try to do this all in your head. Jot it down. Label things like I did so you can underline or circle the word that indicates your operation. You can look for the word or the phrase that would indicate equality. Take your time with these, okay? If you can't master this simple concept, the rest of problem solving isn't going to go very well because all of problem solving is based on direct translation, okay? So really work at this. If you need more examples or more help, let me know. I'm happy to help you. You can either join a Zoom meeting, okay, and we can go over examples on Zoom, or I can come up with worksheets. I have tons and tons and tons of worksheets from the old DMA classes that we used to teach. I can also make more videos, okay? You just got to let me know what you need, okay? If you have any questions, send me an email. Take care.